All right, calculus, time for part 2. So what we need to do now is take this data and input it into Geogebra so we can do some math with it. So our last 2 columns here, we're going to highlight these, copy and paste them. So click on the J, that highlights the J, hold shift, click on the K, that will highlight all of K. Now you can copy that, Control C. Now we're going to go to a website called Geogebra. So geogebra.org. And because we're working with spreadsheets, you're going to click on Spreadsheet here, and it's going to open up a spreadsheet for us. So click on Spreadsheet. Takes it a second. So now we've got our graph over here, we've got our spreadsheet over here. So click in the spreadsheet, top left there. Now you're going to paste that. So Control V. Now when you do Control V, it might take it a second or two to load the numbers in. Okay, so just do it once and then be patient. If you do it over and over again, your computer will get very, very angry. So now that we've got this pasted in to our spreadsheet, I'm going to sort of resize this a little bit. Now it does do one annoying thing. It puts this here. So I'm going to delete the table in my graph. So click on the table in your graph, hit delete. You can even delete these points over here. There we go. Makes my graph nice and clean again. So come back over to your spreadsheet, click in the spreadsheet. Since I clicked out of it, you can see my menu buttons up here changed. And so we're going to turn these into points on the graph. So to do that, click on A, it'll highlight all of A, hold shift, click on B, so it highlights all of B as well. Then you come to this tool right here, the 1, 2, and then you want the second one, list of points. Click on list of points, and now it just says, hey, do you want to make all of these points on the graph? And you're going to say yes. We do want to take a moment to recognize that the name of this is L1. We're going to have to use that in a bit, but that's L1. If you want to change the name, you can, but I'm going to leave it as L1. So when I hit create, is going to make all of those points. Now you might say, hey Bolt, where'd they go? They're not there. They are, we just have to find them. So we're going to change the scale. So if you click over here, you should now be able to hold shift and then use the up and down arrow. I'm going to use the down arrow here to bring the points down. There they all are. And they're all scrunched up on the x-axis. So I'm going to use now keep holding shift. Now use the right arrow to stretch them out to the right. And there we have our data. There is our force curve for our rocket. The acceleration curve for our rocket. All right, now it's time to do some equations. So you have to bring up the equation bar. So you come up to the 3 bars here at the top right, and then go to View, and then the first one, Algebra, will let us type in some equations. So click on that. It might take it a second. I'm going to click on the 3 bars to make that go away. Resize a few things here. There we go. So now I can see my spreadsheet and all my algebra here. So the algebra has a bunch of points. Those are all the points we created. We don't really need to do anything. At the bottom, though, there is an input bar. So now we're going to make an equation that fits these points, and then take the integral of it over and over again to get to position. So this is my acceleration curve, so I'm going to say A at x is equal to, so this is my acceleration equation, and so the command we use here is called fit poly. Fit poly. It's going to fit a polynomial to a list of points, comma, the degree of the polynomial. So what's the biggest power you want in the polynomial? So I'm going to hit parentheses. So the first thing is it wants to know what list. It's L1. Now it tries to do some math. There we go. It's kind of angry. That might take a while. But again, now we're going to tell it what degree we want our polynomial to be. So you hit comma. And so a good one to try is 19. You could try 19, 20, or 21. Those are all good polynomials that you can try. I'm going to start with 19. And so that then makes a 19-degree polynomial. You can see it's a massive number, x to the 19th, and then it goes x to the 18th, x to the 17th. It's a very big, big equation. But as you can see, it fits those points really, really well. So now we actually have an equation to work with. That's what we can do calculus with. So that's acceleration. So now we need velocity. So v, at x. Well, velocity is just the integral of acceleration. So integral of acceleration, we called that a. So I'm going to take the integral of a. Hit enter. As you can see, the degree of the polynomial went from 19 to 20. That's just the power rule. You add 1 to the power. So now we have our acceleration curve, and now this red one is the velocity curve. All right, we got to do that again to go from velocity to position. So p at x, we have to take the integral again. So take the integral parentheses of v. So take the integral of velocity. As you can see, we went up to a 21-degree polynomial now. And now we have a curve right here for position. Now, one thing to remember, this is only the position while the rocket is burning, not while it's gliding through the air. So if I go back to my Excel file real quick and look at the times, scroll down, this is only lasting until 0.88 seconds. Okay, so these equations that we just made are only good for 0.88 seconds until right about here. Once we get to here, the rocket engine cuts off, and then we're gliding. And so once you're gliding, those are the equations we worked on together, that's when only gravity is acting on the rocket. And so we need another equation for just gravity. And so for that equation, we need to know the velocity. All right, so we need to know, we're going to call that v, the velocity at 0.88 seconds. So how fast is this rocket going when the rocket cuts off? 46 meters per second. Then we need the position when the rocket stops burning. So that's the position at 0.88. How high is the rocket already when it starts to glide? So that is at 23 meters. So it's 23 meters in the air when the rocket cuts off, but it's going really fast, so it starts to glide. So this is going to be our position 2 equation, P2 at x. So this is our gravity equation of negative 4.9 x squared plus the initial velocity, which was bx, plus the initial height, which was c. Hit enter. And so now this equation describes the position while we're gliding. And as you can see, it's a really shallow parabola that goes up and up for a long time. Our rocket glides for quite a few seconds before getting to its maximum height somewhere over here. And then the parachute pops and it glides back down. So, got 4 graphs here, it looks like. First, our acceleration curve. Then the red one was our velocity curve. Then the blue one is the position while the rocket's burning. And our orange one here is the position while the rocket is gliding. So, then to find the maximum height, you simply find the max of this equation. Take the derivative, set it equal to 0, and then plug it back in to find the maximum. All right. Good luck with that. Hopefully you followed it.